Hello viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about SpaceX Starship IFT-3. So let's dive deep into it. So what exactly is this IFT-3? Well, it's a big event on a Pi Day. On top of that, this was 22nd birthday of SpaceX. So yeah, SpaceX is only 22 years old. It was started in 14 March 2022. Damn, they are moving fast compared to every single space agency on the planet. So this was their birthday gift, the biggest candle, and it was a full stack test, meaning basically launch the rocket as it's doing a mission, full launch. And the reason why they have to start to pick up the pace is simply because Artemis deadlines are coming close, so they have to show tangible progress in order to secure a bit of money, so to say. And this happened on Tuesday, 14 March 2024, 6:55 p.m. Indian Standard Time. I did a live stream of this yesterday evening. When I'm recording this video, it's just one day, so not a lot of details have come out yet. So what was their aim? You can only judge them based on what they were trying to do. So their core focus, like if this does not happen, they will classify this as a fail. It should be better than the second test. Let this be very clear. Better than the second test does not mean complete, everything happens. That's awesome. If it does not happen, how bad it is, that will be directly contrasted to launch 2. So launch 1, launch pad was destroyed, the tower was damaged, and the ship was damaged, and when it tried to detach, it basically failed and it went boom. So second one, okay, launch pad was survived, tower had minor damage, and then the detachment happened properly, but then it started to went boom and super. So that is the mark they have to beat. It has to become better than launch 2, not better than the everything else, just better than launch 2. Now, what systems they were testing? Systems wise, redundant Starlink coupling. You must notice 4 packs on this. Now, why they are going this route? Well, you have to understand, Starlink, when it's on the ground, it has the luxury of being static. Only satellites are moving. When you are on a rocket, your field of view, basically how phase array shift dish is looking and how quickly satellites are going, that would become ludicrously fast. You are talking about orbital velocity from your vantage point because you are so close to it. You are, let's say, 220 kilometers up and the satellites are barely 300 kilometers. That's going so fast above you that it's very hard to lock on based on just few satellites. You need much larger array. So that's how they got such a good feed throughout such a large range, because if they had a certain data link that was going through geostationary, then they would have a better chance. But because Starlink is a not even medium earth orbit, is in low earth orbit, it is very hard to do. That's why the basically telemetry comes through medium earth orbit or geostationary. Those are far more simpler to maintain, but throughput is much lower. So testing of redundant Starlink and upgraded hot staging. Hot staging last time did work. If this rocket was a use and throw rocket, like 99.9999% of the rocket, it would have worked. But because this is a reusable system, they had to kind of make sure that booster survives. So they had a different upgraded algorithm for that. And in orbit propellant transfer. This is a requirement for Artemis mission, so they can show NASA that they are actually developing something and they have some tangible progress to justify the next batch of fundings. So that had to be done. Test Starlink satellite doors, because you have to understand, if you remove Artemis, this is so big, so oversized that there is not that many projects for it. Meaning, at best, 1 or 2 launches a year. At best, I'm stretching way too much. Realistically, it's oversized. So what is the requirement? What is the prime requirement? What is the prime customer? SpaceX itself. For Starlink. Starlink is in an ugly spot right now. It's growing, but it cannot grow because the rocket is the weak link. So they need a big ass rocket. So this is a big ass rocket. That's why from day one, this rocket was designed from from inception to be a basically ferry service for Starlink satellite. The larger, big, huge satellites. So they had to test the door and booster landing propulsive systems, because again, booster not only has to detach while it's firing its own engine, it has to yeet out of there very quickly, decel as quickly as possible, shut off the engine, come close to the ground, fire the engines again, and then safely do a quote-unquote splashdown. Raptor engine in space reignition. Now that is a bit difficult because again, it's not difficult as in like law of physics. Be mindful, we have a methane engine that has been reignited on moon at this point in time. So it's not impossible, it's just tedious, and again, you have to verify it. So that was also a verification. If they can guarantee it that they can reliably trigger the engine on and off, it allows them to explore much more orbits. Like the capability gap opens up. Uh, Starship safe and stable re-entry. Be mindful, this is a blunt body re-entry. It's not a glider, so it's a bit more different. It may look like it's entering exactly like a space shuttle, but space shuttle is a bit more different compared to this one. So this is going wabam to the atmosphere. So it does require a bit of a control. If they do not, safe and stable re-entry does not happen, it goes boom. And then you have the safe landing burn also. It also has to fire some engines. So these were the aim. And if all would have went according to the plan, at some point it would have done splashdown in Indian Ocean. So these are the aim from SpaceX point of view. So what is the result? Result is passed in some things. What are the things? Perfect rocket launch. Because if you have noticed the launch, it was quick, it was snappy, it was like launch, go. Like a launch pad, the launch tower, none of them had any issues. Like go. Done, sorted. This puppy sorted, go home. So that part is sorted. Max Q at this point, they do not even consider it as a series. Heck, I do not even think they even announced it that it was going through Max Q. It was like, bro, I got this, do not worry about it, I got this. Then hot staging was flawless. It did that, and it did not boomed the booster instantaneously, so that was a really good signature. Then booster did not explode. The booster exploded apparently because it has a lot of sloshing, which dislodged something. That dislodged something blocked the filter. So this time they had reinforced filter, and I'm reasonably sure they must have reinforced the interiors also. And Starship did not had any fire. Last time Starship was overweight, so they were dumping oxygen, but you are dumping liquid oxygen. Yeah, and you have a rocket exhaust at the bottom. So you have heat, and you have stuff, and you have liquid oxygen. That means you're gonna catch fire. So this time there was no fire. That means they, all the mitigation stage they did paid off, no fire. And it reached its target path, meaning where it's supposed to go in the orbit. It was not designed to go complete orbit. It was designed to go almost at an orbital path, but a bit of a ballistic trajectory. So it did what it's supposed to do. You cannot go, oh, it did not went to orbit. It was not designed to. They were very clear from day one. This was the clearance from FAA that we're gonna do this. They did this. So fundamentally successful in that regard. So these are the pass marks for them. And launch was like fabulous. Unfortunately, the weather did not cooperate, so all the awesome cameras that we had on the site, those did not get their days to shine. Somebody put a global shutter 6K camera, and weather is like, nah, bro, nah. That's like a ouch. That's a big ass ouch. So these are the past results. Unfortunately, they also had some fail results. So fail results, the biggest fail was booster failed to do reignition again, meaning once it do the diesel burn, it shut off the engine, landed it doing this, and then it tried to reignite the signal. Yeah, that time it did not happen. Why? I do not know. Most likely, if I'm just guessing out of thin air, most likely it was oscillating too much, so the fuel became and I did watch it in the live stream. It was like, it was going too much dinka. So it failed. And when did it fail? 0 kilometers. So it's less than 1 kilometer when it went boom. Now it could be a safety system trigger or something bad happened, but likelihood of something bad happening is very low, simply because it did not have enough propellant to go boom. So it would require something else to make it go boom. And because of the bad weather, we do not have very good, as of now, when I'm making this video, maybe some better videos will come out tomorrow. But as of now, I did not find any amazing results where it's like, okay, this is where it happened. Now, Starlink door also failed. That was very weird because, again, it was 50-minute. And yes, I was doing live stream. Yes, I'm sorry if you watched that video because I'm eating there. Yeah, I was hungry. So the door did, and that's it. Door was not like open, close. That did not happen. So door was very odd. So door was not a very good success. And Starship, basically, when this puppy tried to re-enter, it lost control. If you watch at the signal, it's like, it's going, it's even in their own animation, it's supposed to go like this, a very controlled way. How it was doing is like this. It was going edge on, meaning half of the part was protected. If you want to understand it, watch the video fully, and you will notice that flame directionality is not parallel to where it should be. Basically, this whole back part side supposed to be basically heat tile side should be facing the plasma. Half of it was. So if pay attention to the direction, it's very hard to explain, but pay attention to direction, you will start to notice, okay, this is not going in the right quote unquote direction. So it did lost control and it was tumbling. Basically, look at the graph they have that is showing the how ship is rotating. It gives up midway. It's like what is happening? I have no idea. And you can say like the whole scene is rotating like this. Something bad happened, like either it vented too much, OLS thruster did not have enough authority. It was trying to move wings, but it was trying to do that in Well, low Earth orbit, it was not gonna do much. You can see that, like in the video, you can see that it's like trying to move all of that, but not much is happening. It had to wait quite a while, then it started to hit the atmosphere, then it started to actually take effect, but it did not stabilize. So it also had much of a lot of random oscillations, exactly like this puppy. Now, why we are facing with this? Well, you have to understand, be reasonable here. Nobody has done something like this. There is no manual. Like if you are building a fighter jet, there are manual. It's like, okay, this is how you design the aerodynamics of it. Here, yeah, what are you trying to land? A giant skyscraper, stainless steel, based on engine thrust while it's falling from almost half of orbital velocity. Yeah, we do not have a manual for that, so they are writing the manual. So there's a very good chance the control authority vector mathematics was not refined enough. To be expected, let them be expected, to be expected. This is the first time. All the computer simulation is just that, computer simulation. Because of the size, because of the dynamics involved, it would be hard to get right. And plasma did hit the unprotected part. That is very clear. If you look at the, pay attention to the plasma glow directionality, you'll be like, okay, other parts are getting. And yes, during that, when it was unstable, it did had enough parts falling out of it. Some did look like a heat shield. This time, during takeoff, heat shield parts were surprisingly intact. There was no heat shield shower. This time it was very intact. However, during the, when it started to do re-entry burn, that time it was like shedding things. Ship went boom afterwards, because it was kind of expected. If this side was getting attacked by the plasma, while stainless steel will allow it to hold out for a few minutes, which we did see, it's not gonna hold out forever. So it did went boom. So it did fail in many things. Now, what can we expect in the future? Now, you have to take a break here. I've seen way too many people, even smart people, trying to justify or go against it. You have to be reasonable with it. What does that mean? That simply means, are they making progress? Are SpaceX making progress? They are making unmistakable progress, meaning where they were when they first launched it, where they are right now, it's exponentially further. That is the first thing. Another aspect is, it's not perfect. Let that be very clear. The perfect would have been the proper re-entry burn, at least of the Starship, and not of the booster. Booster will take some time, but if at least they would have gotten the Starship, that would have been awesome. But that did not happen. However, they still made tangible progress. Now, every test is getting better than last. Compare this to, let's say, N1 series of rockets. It was just going boom, launch, boom, launch, boom, launch, boom. That's all it happened. Here is like, what happened? You launch, it boomed the pad, it boomed the tower, it damaged itself and did not detach properly. It went boom. What happened the second time? Tower, pad, both were, pad was like, I got this. Tower, minor injury. And then the rocket was mostly intact and then it detached properly. But that sloshing was too strong, so it had issues. And then the fire caught an issue. Okay. Third one, what happens? Launch pad, we good. Launch tower, we good. Rocket, completely intact. It does proper detachment. Everything works fine. And it reaches almost to the end point where it's supposed to go. The orbit part, if it was a disposable rocket like SLS, this puppy is already a success. It was success in test 2. This here is like, dude, we done. As a disposable rocket, they want to make it reusable, so that is why they are difficult. So they are getting better. If this was like, okay, if it blew up in the pad, then it will like, yeah. Although you really do not want to see that, because it would be a miniature nuke if that happened. Now, what are they learning going through this much physical stuff? They are learning mass production. And be mindful, right now SpaceX is on a pedestal. That pedestal is so high that you take SpaceX, everybody on the planet, SpaceX still will win. It's like, it's not even funny anymore. It's like, bro, no, nobody is even close to it. Not the great China, not the USA, nothing. It's like SpaceX and nothing else. So fundamentally, how the heck they achieved it? Mass production. And what they are learning with Starship going through physical prototypes this fast, mass production. They already have 4 boosters ready to go. They already have 3 ships ready to go. They're like, bro, we sorted. Every feedback they take, they can fine tune it. If it requires complete new build, they can still do it. How can they do it so quickly? Well, that's what they are learning, how to make sure the Boca Chica is the printing machine, where it's like, bam, bam, bam. Compare this to SLS. Yes, SLS achieved a full success in one go. When is the second SLS? And if you compare first SLS to second SLS launch, then this will be like, whoa. So that's the whole point. And no one, there is no instruction manual here. There is no one that has anything even comes close to the complexity, scale, and cadence of it. That's horrifying. Like, all 3 has to be matched. Otherwise, it's flat out impossible. Be mindful, other countries will take 2 years to launch a rocket of this caliber. They have to launch this puppy almost 2 times a month. Or maybe even quicker than that. Only then they can refuel it before it boils off. So fundamentally, the cadence required, the scale required, the complexity is exponentially greater than anything so far done. So yeah, it will be difficult. Now, how far they are, like if I'm creating a progress bar, how close they are to 100%? They are 90% there. That means it's a good thing. Actually, no, because the last 10% is the painful one. If you watched Falcon 9's development, you will notice they got to the orbit surprisingly quickly. Orbit to safe boost back burn very quickly, but actually landing safely without going boom or without tipping over or without running out of T-taps, that took way too long. So it's one of those saying, any project, take rocket engine or software, it's like the last 10% will be the most brutal one. So SpaceX is at that point. So I could easily see them reaching orbit reliably by fifth iteration, but still would take 10 or maybe 15 to get a point where they're like, okay, re-entry is sorted now. So they're doing that. That's hard to do, but not impossible. And to give you some context of it, Saturn V, basically when America was building things like there was no tomorrow and there is no money limit, blank check, that time each stage was taking 1 to 2 years to build. They are reaching a point where they can build complete from start to finish two rockets in that time. Complete rocket, both stage, which is supposed to be reusable. So fundamentally, it's on a whole different level. It's exactly same philosophy which NASA is taking with CLIPS. They know for a fact CLIPS will fail far more than any NASA mission, but they know if they allow that failure to happen, they will build a better pipeline, better supply chain. And benefit of that is once it's all done, then you can be like, okay, bro, I got this, I got it. Or somebody's like, oh, we need to go to moon. Bro, moon. It's like, done, sir. Take it and go. So to reach that point where you take it and go, you need to go through this painful option. Because remember, the only other company that can match this in principle is Blue Origin, which is supposed to be quote unquote buying ULA. Again, I'm not sure when this is going to happen, but or maybe this may not happen, but yeah, very far. So as of now, SpaceX is moving slowly, more slower than anticipated, but methodically. Everything is happening exactly out there. And progress in Boca Chica, the only thing missing is like, why the heck they do not have an air distillation tower? Like, is the only thing I can logically come up with is they do not have power budget there. Meaning, last time I saw they did draw a 33 kV power line, but I think they may need a bit more high kV than that. 130 kV, maybe. Because it does not make sense, because you are paying for someone else's tower plus their transportation. If you remove that, have their own air distillation, you get nitrogen, you get argon, you get basically oxygen. Nitrogen and oxygen both are main consumable of Boca Chica. Sorted. And argon they can sell, and again they may be able to use it on their own system. So I'm genuinely shocked they have not built it yet. The only reason I can logically come up with is that power budget is limited. Like they do not have a way to draw megawatts of power there on site. Extra megawatts, whatever they are drawing, plus few megawatts more. So this was my presentation on SpaceX third Starship launch. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.